Let's factor the quadratic 1x squared plus 1x minus 12 using the AC method. So all trinomial quadratics would come in the form of ax squared plus bx plus c. So our first task is to figure out what is the a, the b, and the c here. A is the number attached to x squared. It's going to be a 1. B is the number attached to the single x term. That's 1 as well. And C is the number that's alone here. That's the negative 12. Okay, now that we identified A, B, and C, part of the AC method is to, on the side, multiply your A times your C. So we're going to get 1 times negative 12 here, which makes negative 12. And you do want to keep track of the negative, whether it's negative or positive, that matters. All right, next, I want to list all the factors that would multiply to negative 12. And there could be a lot of possibilities in some problems. Let's see. We would have negative 1 times 12 would be a possibility. Negative 2 times 6. Negative 3 times 4. And we could also switch the negative to the other factor. So 1 times negative 12, 2 times negative 6, and 3 times negative 4. Okay, our job now is to find what I call the magic combination. This is two factors that multiply to negative 12, but also they need to add to the b. They need to add to 1. So they have to multiply to negative 12, add to b equals 1. All right, so check out the combinations. Negative 1 times 12. They would add to 11, so that wouldn't work. Negative 2 and 6, they would add to 4. Negative 3 and 4, though, yeah, that's it. That's the magic combination. They multiply to negative 12, but they also add to a positive 1. All right, now that we have the magic combination, it's time to go on to the next step. And what is the next step? It is to change the b just a little bit. You leave the a, x squared, and the c part alone. But what we're going to do is we're going to rewrite the b term and break it up into two parts using the magic combination that we had found. You use negative 3 and 4 in this way. 1x could be broken up into negative 3x plus 4x. Wouldn't they add to 1x? They would. But we need to break it up. The reason why we break it up is because what we have now is going to be factorable by grouping. So let's rewrite what we have. And if we chose the right magic combination, then we don't have to reorganize the terms or anything. All we have to do is just put parentheses around them in the positions that they're in now. And now we just have to factor out what they share in common. So I see here on the left that they share an x. So I'm going to pull that x out front, leaving behind x minus 3. And then here I see that they share a 4 in common. And if I do divide out that 4, we're going to have x minus 3 there. How did I get those? Just in case I lost anybody on that step. I pulled what they shared out front, and then I divided by it as well. And over here, they shared a 4, so I pulled that out front, but I divide by 4 too. That's how I got to what I have below. Now there's just one last step to do. That's put it into its final factored form. We bring the x minus 3 out front and leave behind our x and our 4. All right, the problem's done now. And you may notice that the numbers that are in there happen to be the magic combination. Aren't they? Here's the negative 3 that we had found right here. And here is the 4 that we had found here. So you might be thinking, could I just jump to the final answer if I know the magic combination? Could I just assume that it's going to be two binomials using x and x, and then I put a minus 3 and a plus 4 because that was the right combination to use? And the answer is you can do that. You can jump from here to here if a equals 1. That's the critical thing. If a doesn't equal 1, then that approach will not work, and you have to go through all the steps that I just went through. In many quadratics, unfortunately, a is not 1. So you have to use the full AC method that I just showed, including the factoring by grouping.